Sweet. Apurva, thanks so much for coming on.
Thank you, Ashaya, for inviting me.
Perfect. Yeah, so there's a lot I want to talk to you about, regarding AI. But first of all, what's kind of your journey been like into AI, ML? So we can go over that.
So I did my undergrad back in India, and that was in electronics and communication because I never wanted to code. But then through my engineering, I realized that I was into embedded programming, and I realized I do like coding. So after I graduated, my first job out of there was as a software engineer. And then I joined a startup which was building humanoid robots in India. That was like the first company doing that. And that's where I was introduced to machine learning. So they were like using the bots to pick up stuff. So computer vision was what they were using.
Yeah.
So I was introduced to machine learning there. And then I came for my master's to University of Waterloo. And during my thesis as well, like I made sure like my thesis was using machine learning. It was directed towards the field of artificial intelligence. So my thesis was called Cognitive Driver Distraction Detection. So like when you're driving and you're thinking of something else.
Right.
So it's hard because you're not looking away from the road. You're actually looking at the road, but you're thinking about your grocery list.
Right.
So it's hard to detect because you cannot just look at the pupils and see like it's looking away from the road or not. So we were collecting physiological data, your heart rate, your electrodermal activity, and then we were also collecting your heart rate data, your eye tracking data, and your driving data. So like the lane positioning, your speed, braking, all of that. And then we use machine learning algorithms to like figure out if a person is distracted or not. And we found like it was a good research. Like we found like eye tracking is like the best way to detect if a person is distracted. And this research was important because autonomous vehicles are not yet at level 5. So like people would have to take back control from the vehicle, and you need to know if the person is attentive at that point to take back control, assess the situation, and make a decision that the vehicle cannot. So it helps to like keep track whether the person is attentive or not. So that was my segue into like machine learning, AI, and after that like I worked in a number of companies in that field.
Yeah. So interesting. Yeah, that's a great topic. Especially because those algorithms that are used for vision and like driver distraction can be used like applicable throughout different domains, right? You have or the
Yes.
style of research. So how did that help you kind of transition to other types of jobs? Because I know you've done a lot of consulting, a lot of different jobs.
So even through my masters, I was working part-time or as an intern in like multiple companies. One of the first companies I worked with, it was called ClearVoxel. They were trying to detect if a person is distracted or not, a radiologist is distracted or not distracted while going through medical imaging. So the whole idea was that they have to go through like number of images, and if they are distracted, like they could like make a decision or like say that there is nothing and there was cancer in there or something. So it was more to put like an eye tracking device on the system, and it'll keep tracking their eyes. So what the literature till now had shown that when they go through these x-rays or medical imaging, they like follow a pattern. They start from like the top left corner and then they go in a zigzag fashion or like some sort of fashion or pattern that they always follow. So if they're not following that pattern, if it's an anomaly, then they are distracted or fatigued or like something else is going on in their mind and they're not attentive. So yes, like I applied the exact same thing in a different field. So that was very interesting. And what else? So after that, I think I consulted with. No, I was working for your startup, right?
Yeah.
Honeycomb.ai. So like that was also very interesting, like finding allergens in menu items. So that was my segue into natural language processing actually. So till then it was just numbers and eye tracking data and all of that, anomaly detection. But that was my segue into natural language processing. And after that, like once I graduated, I started working for a company which was building bots for the insurance industry. So chatbots for insurance industry. So that was one. Then after that, again, I was working in a company where I was building personal assistant. So this is I'm talking about natural language processing before LLMs came into picture, because now all of that is not even necessary. For example, like in the company where I was building a personal assistant, like it had to figure out if someone says, "Can you book me an Uber from point A to point B?" It has to figure out that this person wants to book an Uber, so the intent is to book an Uber, and the entities are point A and point B. Point A is the origin, point B is the destination. Like all of that, like NER detection. So we had like different algorithms. Like one was to find the intent, the other ones were to find the entities, and then figure out what is happening, make the API call, book an Uber, send back the details to the person, all of that. So it was hard then, hard building those systems, because those models were amazing, but they weren't at the level of LLMs. So that was very interesting. And after that, I've been working with this company called Truckstop. I've been here for like 3 years now, but haven't been working in the field of natural language processing. But we did like a couple of POCs with LLMs, and it did work really well. But I have been consulting on the side, and LLMs are doing good. It's just, it's not production ready as such. But there are a lot of other users,
Yeah, exactly. So why don't we go into that? What are some of the reasons why it's not production ready? Because I know you're big into MLOps too. So there's the ops side, but then there's also the deterministic side. What do you think are the biggest problems with LLMs in production today?
I would have said hallucinations to start with, but you know what? Hallucination is also a feature, because you want these models are creative. Like I was reading it somewhere that, to be honest, like they are just hallucinating all the time, but sometimes like what they say matches with the ground truth, and we think like they are not hallucinating. Look at that, they just do it like sometimes. Because it's just like all of the internet's data out there compressed in a compressed form, and then it's like generating answers. So it would obviously make mistakes.
Yeah.
It's not A to A, like it has been compressed.
Yeah,
so
Karpathy said they're just always dreaming all the time.
Yeah, exactly. So it's not their fault, or it's nothing wrong with the LLMs. It's basically the system that we have to build around it, so that you can actually make a tangible product out of it and give it to the users. That is what is more important. And it's a lot of hard work. It's not just easy. It's not that easy. Like people make demos overnight and they're like, oh, LLMs are going to change the world. I see so many Twitter threads in which they're like, LLMs can just become the next software. It's not yet there. They cannot. But if you build a system around it, yeah, they can get you 80% of the way there.
Yeah, exactly. Yeah, and that's what we found as well. Like it's basically, I see a lot of people that are using LLMs as one hammer for all different problems. Like classification, use an LLM. Like even vision tasks where people are using the multimodal models. Like how do you find what do you say when someone comes up to you is consulting and they're like, this is how I want to do it with LLMs?
It's so overhyped.
Or how do you convince them otherwise?
Yeah, it's so overhyped right now, if there's a classification task, it's not necessary for you to do LLMs. There was machine learning before LLMs, like classical machine learning. People are forgetting about that. It's so much more reliable. Systems have been built for those things. It's so easy to monitor them. And some of those algorithms are not even a black box. Like, why do you want a big black box to do stuff? Like, you're using a sword to cut an apple, which is very unnecessary, So I generally, I go with the cost, but the cost of LLMs have gone down quite a lot as well in the past few months. But mostly, if you explain to them, what machine learning has been through the years, and LLMs are a new entity altogether, systems are getting built, we have to figure out, how do we put it in production, and I can give them something more reliable for more cheaper, they always go with that. Yeah.
Nice. Yeah. And so taking a little segue, I know you're doing a lot of educating and doing some stuff with kids. So you mind talking about that?
So me and my husband actually have been very much interested in childcare. It's so important. He has a company in which he provides SaaS software to nanny agencies and childcare agencies. And what we're realizing is childcare is so expensive. Anyone, even in Vancouver, you talk to anyone and they're like, you have to sign up for a daycare right when you're pregnant, because there's a long queue. And it's expensive, even though I think the federal government has said you can have daycare for $10 a month or something, but those daycares have a long queue. It's a 3-year wait or something. So we are exploring solutions for how we can build some sort of assistive technology to help out with childcare for mothers. So in the beginning, I started with an organizing tool. So if you have multiple kids, it'll help you organize activities, distribute work among you and your husband. So that was how I started, and now we are getting into like robotics and stuff as well. So we're still exploring, but I feel it's very important, and everyone should think about it, because all the governments are realizing it now, that the population, like the young population, is going down, and it's going to become a really big problem at one point. And I hope like people would start putting money into this problem sooner rather than later.
Right.
That's, yeah.
Yeah. So no, that's a really noble cause, and I'm sure it's definitely needed for sure. So going back to kind of your problem solving, you've done a lot of different problems. Do you have an approach you look at? Like, what are the key things you look at when you're approaching a new problem? 'Cause I think people would really like to know like what someone like you does in problem solving.
Interesting question. So when I get a problem in a new space, I'd start with like exploring what's already out there, and why it did not work, and then start figuring out a solution to that. But it is an iterative process. That's the most important part. Like, it's an iterative process. Like, even if you're like trying to build your own startup, like you have to figure out if there's a market for that. So you come up with a solution and see like what's the traction you're getting. Are people interested in it? Like, what's the most basic what I've heard is like, if you have found a solution, make a website about it and see how many signups you get, and like maybe make them pay a token amount for the sign up, and see, because at the end of the day you need paying customers, and that is how your startup is going to be successful. So that is important, but the most important part is like, the first solution that you come up with is not the final solution. It has to be an iterative process. So even like with the childcare solution, like we are right now like testing it out with like field testing it with kids. Like every kid that we come across, like after that we have to like make like 10 different changes, and then we test it out with the next kid, because you learn so much. And it's so important to like field test your idea, right, with the customers, with the users. Customers would be parents in this case though, but with the users. Yeah, that's important.
Awesome. And so let's say you're looking at comparables between like a vision problem and maybe a language problem. What are some of the things that you find are like common patterns between those two sets of tasks?
To be honest, like the common it's okay. So for vision, what I've noticed is like, there's video and there's images. So with video, like you can break it down into pieces and make a model like work on it as an image. You break it into like each frame and then you work on it. With the same is what happens with like language models. I would say like they break down a sentence into tokens, but like it depends on the architecture of the model, like how it works on it. It can work on it in parallel. It'll break it down into pieces. So that varies based on the architecture of the model. But at the end of the day, like you break your input down into pieces and then you work on it. And how you want the inference to work as well. Like I was recently looking at the SAM2 demo. Like it's amazing. It's amazing like how well it works, and how efficient it is, to be honest.
I still have to try it out. I mean, I have to try it out.
SAM2 is like really amazing. And like at least like cause of LLMs, like it became so popular. Like we are actually exploring architectures other than transformers, which is also very good.
Yeah, so going into that, so there's a lot of companies who have like kind of gone all in on transformers, right? And like a lot of funding into just saying that transformers are going to be the be all end all. What do you see as like the use case of transformers in the future? Do you see other things you've kind of come across that you think might be more promising in the future? Or is this like the golden architecture we've stumbled upon and now it's just a matter of like throwing more data at it?
So I've heard like people on both sides actually. But at the end of the day, what is like with any big model, what is important as generalization. So you can build a reliable model for a narrow use case, but what is happening is all these bigger companies are trying to build like a generalized solution. And that is the same case with like autonomous vehicles, right? Like you're trying to build a solution for autonomous vehicles, and it should be able to like think of every scenario. Like when you're training it, you should be able to think of every scenario that this vehicle is going to come across and is able to make a decision, and that is how it's autonomous.
Right.
But honestly, like there's so many edge cases. You cannot train a model on every edge case out there. That is what real world is.
Yeah.
Like there's so many permutations and combinations out there. Like you cannot train it on every data out there. So there needs to be an architecture shift for sure. You can throw, and the models do improve. Like you give it good quality data and you train it at scale, they do improve. But would they generalize enough to every use case so that you can build an autonomous vehicle is the real question. Like,
Right.
Or would it be, the other thing is, would it be smart enough if it comes across a situation that it hasn't come across in its training data to make a decision on that, right? And that is why like we have like humans in the loop who are making the decisions still.
Yeah.
Yeah.
Do you think there's an architecture that's like maybe a classical ML algorithm? Maybe it's just, I know like XGBoost, or maybe even just regression that is looked kind of not looked at enough these days for tasks, like a common task that you find?
Ensemble models.
Okay.
XGBoost, Random Forest, CatBoost. CatBoost is like older now, but these are so good and they're still used in companies. Like, there's so many enterprise companies making so much money just out of ensemble models. If you don't have images and you don't have like natural language you have to work with, you just have numbers. Like ensemble models are the perfect solution for it. So simple to put it in production as well. And you can like figure out like which features are important, like a lot more transparent too.
Yeah.
So yeah, and people don't realize that it's just like what is overhyped right now, what is out there in the news, what's trending. But like there are so many companies making so much revenue just with ensemble models.
Yeah, even going back to like recommender systems, right? Like there are companies that are just build recommender systems for others, or like integrate it into their pipelines, and have just made so much money off them. And they were doing this way before LLMs or any kind of models as well.
Yeah.
Have you worked on any recommender system type stuff before?
No, not yet. No.
Okay.
I
Yeah.
haven't,
There's also an interesting problem for sure. But now people are also trying to use LMs like, okay, let's use the embedding of this and then use the embeddings and find similar things and use that as a recommendation tool.
So yeah, RAG is pretty much like a recommender system, right?
Yeah.
So yeah, that's true.
Yeah. So going into RAG, so do you think RAG is something where that's overplayed right now, where every use case is like, okay, if we're running out of either context window issues or hallucination issues, let's just throw RAG at it and see if it solves the problem, or do you find something, you try and do something else before you go to RAG?
To be honest, it depends on the kind of problem that the company is trying to solve. Like sometimes they need like work with their data, the data needs to be fixed. That is one kind of problem. The other kind of problem is in which you're just like working with prompts, you're using few short prompting, chain of thought, like improving and figuring out if the model is able to answer what you needed to answer. The third type is like, what is RAG? Like for example, like I built a customer support bot for a company. They already had a lot of documentation. So you could use that documentation to answer questions. So the thing with people is like, they have a question and they want an answer right now. And we don't even like talking to a chatbot. Like humans do not really like talking to a chatbot. Like RAG became really popular and like every company started building a chatbot. But honestly, like you should look at your users and see if they do like talking to a chatbot or not. So in this company's case that I was working with, instead of building a chatbot, what we did was like, you ask it a question, it gives you an answer, and that's it. That's where the conversation ends. There is no like conversation in which like it's keeping history of what you asked. It's just a Q&A bot. So we put like a lot of documentation there, videos. They had like YouTube videos as well. Their HubSpot documentation, everything behind it. And then we gave them, instead of putting a chatbot window in the front, we gave them like a search bar. and there they could ask a question. So if they have a question, they ask it, it gives you an answer. And if it doesn't answer your query, it gives you like the contact of the human being that you can reach out to or send an email on. So I've seen that it's working well. And the thing with like RAG systems is you just cannot build it and throw it out the window. You have to keep tracking it. It has to be iteratively improving. So there's a thumbs up, thumbs down button. You get feedback on your answers, and not everyone gives you feedback. That's the other thing about humans. They don't give you feedback. We have been like looking at the data, how it's performing, and like we are working on that. Like sometimes it's like I do clustering. So like what kind of questions, like cluster the questions that people are asking and see where the bot is not performing well. Maybe because the documentation is not good, or maybe it's something else. Maybe the LLM is not understanding the context. And the other thing is sometimes a company that is building the RAG, their questions or like the words that are used in their context, the LLM might not be trained so well on them. So like making sure that you're fine tuning or you're explaining this in the prompt really well so that the LLM understands is also really important.
Yeah, I think just to touch on like thumbs up, thumbs down, I think it's actually not the best approach for what companies are doing just from a UX standpoint, because a lot of people don't hit them and they're not that meaningful. Like maybe they just didn't agree with it and they're not telling you that it's a wrong answer. So I think like one of the things that we've thought of is like maybe putting like helpful, like other kind of tags surrounding the thumbs up, thumbs down that at least tells the user, okay, this is why I didn't like this answer.
So exactly. So the thing is, like, if maybe the answer took a while to come, there was latency, and that's why they didn't like it, and they put a thumbs down, even though the answer was correct. So it's very important, like next to it, like asking, did we answer your question? Like, what is the context you're asking a thumbs up, thumbs down for?
Yes.
So I do get it. Like, you should be narrowed down on the feedback as well. Or maybe just people just hate the color of the window or whatever.
It could be anything,
asking,
right?
and they just put a thumbs down. So yeah, that's really important as well. And sometimes what happens is people don't even ask a complete question. They would ask password ? So query rewriting, like a vanilla RAG system is very simple, very easy to make. But then you have to improve on it to make it like more reliable and more efficient.
Yeah, I mean, I've seen some tactics like, just using query rewriting and rerouting and rewriting, and then you have maybe a smaller model that answers some common questions, or just a cache. If it's something that's like, we get questions where searches where maybe 85% of searches are the same searches. It's like, and there are keyword searches too. It's not like it's a complex RAG search. Maybe people don't know they can do like a more complicated search, but those you can just have a lookup and have answers to that. And it's faster too for the user.
Yeah, and that is why, like, even if the system is not yet ready, you don't need to have a perfect solution. You need to put it out there so that you know what are the kind of questions your users are asking. So if they're asking like keyword questions, like you should be doing keyword search in the background. It's not just like semantic search that'll be useful in your case, right? So it's so important to put it out there as soon as possible, and then start working on like whatever data you're getting, like what questions. Even though you're not getting any feedback, maybe just look at the questions that people are asking.
Exactly.
Yeah.
Sweet. So another thing I want to talk about is agents. So they're obviously notoriously unreliable right now. Have you seen any reliable agents, and what type of agents have you seen that are working that are actually reliable?
So the one example of an agentic system that I've seen out there in the world is by this company called Ramp. Other than that, I haven't seen. I haven't tried exploring much, so that I don't know like which agentic system is out there in the world. But yeah, the technology is a bit unreliable, because you are stacking like multiple LLMs. But I have also read research papers in which agentic systems are doing very well. So there was this research paper that I was reading recently in which what they were doing was they were looking at machine translation, like translating from one language to another language. Right. So the most basic translation you can do is like for each word switch it with another language word, right? But there's like this cultural context and there's like other context, and this sentence could mean something else, like they're trying to convey a different thought. So what they did was they built an agentic system in which they formed like a team. So you have the senior editor, you have a junior editor, then you have like a linguistic expert, then you have the person who like does the translation, and they are like talk to each other. Like it goes through this whole process of like getting edited, then getting fixed, then it goes to this person, then goes back to that person. So there's like a lot of back and forth, and it comes up with like better translations.
I see. Okay.
Than before. So that is like, it's a research paper. It's not yet out there in production, but like you can use these agentic system to break down a complex task and solve it. That's
Yeah,
it.
I've seen a couple of similar like that where it's like a very small task where it's just like maybe a limited set of tools and then it's like a very specific thing. Like even Crew AI where it's like you have one really specific thing and it seems to do well at that. As far as a general agent, as far as I've seen, I don't think we're, still that like we're still far away, but
Yeah, if it's a very narrowed down task, like it does really well. But yeah, that's the thing. Sometimes it would go in a loop and keep charging you money.
Yeah.
But so you have to like put like how many steps it can go over, how many times it can do a back and forth. But at least like since it's doing a back and forth, it's like there are so many advantages to using an agentic system. It like lets an LLM reflect, like look back at its answer and see if there's something wrong and go back and fix it, which isn't the case. Like it cannot do backspace and fix it. It gives you an answer, then you tell it like, dude, there's something wrong with your answer, go fix it. So it can do that, and like it can plan. It can like sit together with like multiple. The more people involved, the better your answer is generally. So yeah, I there are advantages to agentic system. It's just a bit finicky right now.
yeah. And what type of stuff are you enjoying working on recently? Like, is there problems that you find really intriguing and stuff you've maybe consulted with recently or at your own job?
So I have been working on the childcare thing recently. Other than that, like I was working on moving from AWS to Azure for my company.
Oh,
So
okay.
like doing the whole setup, the MLOps setup, and like setting up the pipelines, to start the training pipeline, register the model, and all of that. So like setting up the coding environment for them, building a package for them. So that was like one of the big projects I was working on.
What usually goes into like a traditional MLOps pipeline? Like obviously you have observability, deployments, probably CI/CD. What else is there that's major that maybe I don't know about?
So it's like it's a long process. So like there are like a bunch of tracking that you have to do. Like you have to like track your data if your data is good. So you track the features, see if the data is still good that you're training your model on. Then there's the system tracking, like the latency, how is the product doing. Then you have to make sure the third tracking is like, is your model good, like accuracy and stuff.
Yeah.
Like so these are like three kinds of tracking you can do. But like the whole cycle would be like, you get the data and then you do like some sort of pre-processing, get your features, and then you train your model on the features, and then you get your model, and you register it. Like you need to version your model, because what might happen, which is the same with like kind of similar to software engineering, like you push something out, but that you should be able to like go back to your previous version if it's not performing well. And then after like registering the model, the next part is like the inference. So that's a completely different pipeline in which like you pull the model, then you get the input from the user, and then you pre-process the input and then like get the inference from the model for that input, and then show that back to the user. So that in the inference part, like what's more important is like what's the latency like, how many requests it can handle, how scalable it is. All of that comes into the picture. But yeah, those are like two parts to it, like the inferencing part, the model training part.
Yeah, and you find that most, like, because a lot of their observability tools, they're mostly centered around inference. But what are, there's obviously weights and biases and other things that are centered around training. But a lot of the time that is spent around inference. What are some things that people overlook on, the inference aspect? Because I see a lot of people, I built a model, I throw it out to production, and then they maybe put some observability, but that's about it.
So what's important is to figure out whether you want batch inference or you want real-time inference. Like sometimes you can get away with not doing real-time. Real-time is like the hardest that you can do. So figure that out. And then with real-time inference, like you have to make sure, depends on like how you're deploying your model. What are you using in the background? Are you using Kubernetes, or you're using like Azure and like SageMaker have their own thing. They are, I think it's using Kubernetes in the background. I don't remember, but like you have to figure out like how do you want to deploy a model? What's the scaling that's going to happen? What's if you're using, like, for example, you're using Fast API, if you're using Flask, like what's the inferencing like on that? So figure that out. But the most important is like tracking. Tracking all the metrics, like what's the CPU uses, what's the memory uses, and is are the request, what's the pattern in the request, if that makes sense. So like, has the input data distribution changed from what the model was trained on?
Yeah.
So you like that would help you decide about like retraining. So that also again depends on the company. Like sometimes it's just like at a cadence, you do it every week, or you do it every day. Sometimes you have to do it because the data distribution changed. Like something happened, COVID happened, and the input data has changed quite a bit. So yeah, those are the important things. But what I'm getting at is like tracking everything is very important, so that you can like work on fixing your solution.
Yeah, I remember you were telling us about that way back, like when we were first kind of starting out, and we were like, okay, just let's try and measure everything so that we have everything, and then get the data, right? Because that's a hard thing as well, right? A lot of companies don't have the best data, so your model can only be as good as that. So
Exactly.
So shifting gears now, because we've kind of talked technical, but in terms of high level, what are some interesting use cases you find for normal people, the everyday people that is it just maybe GPT? Is it kind of copywriting, image generation? When you're talking to a lot of these people who are maybe new to AI, what things interest them the most?
Oh, wow. How would they get excited? I've given like a lot of presentations. Some of them are to technical people, some of them are to non-technical people. You know what gets them the most excited? When it can generate images similar to me, but that wasn't me. Or like it can generate me talking, but that wasn't really me. So that gets them so excited about AI, that because they never thought that could happen, and now it's possible. So it's pretty cool to see how excited they are about that. But like day to day in terms of like uses, it depends on like what job they're doing. Like for example, if they are a designer, they can like they can use like LLMs to like help with ideation, look up ideas. It's interesting to see like what kind of use cases it could be used for depending on which job the person is doing. But I feel like it's useful everywhere. At the end of the day, like as a white collar worker, like you have to write emails, and it's good at writing. So, and it can like fix your emails. Like for example, I'm not a native English speaker. Like I find LLMs really useful to like, that's my personal use though. Like I find it really useful to like fix my emails, fix my grammar. So like helping me with writing.
Yeah. And so what about for SMB owners? I know you've talked to a lot of them where maybe it's, a mom and pop shop, or like a restaurant, or like a cafe, or maybe it's like a grocery store. And you found some interesting use cases there where you can really help them out as well.
So what happened with ChatGPT was AI, ML, all of this was already there. What happened was ChatGPT came into the picture, and it made AI, ML cool. Like everyone got to know about it. Everyone wants to use it. So that's amazing. So that's where I come to like SMBs. Like as SMB owners are like really excited about using AI. They don't have a lot of data, but that's like good enough data for a generalized model. You can just give like 1,000 examples, a few hundred examples, and it would like understand your pattern and can like help you out with whatever. So that is very exciting. And I've seen like a couple of owners that I spoke to. This is like vision focused use case. What they were saying was like this person, like she has her own clothes shop for children. Every season they have to take new pictures with their new clothing.
Oh, I see. Yeah.
For the with the children, so they have to like get the children, get like a photographer, get the space to take the pictures. She's like, is it possible that I take the pictures once and keep replacing the clothing on them? So like there are tools out there which I've explored, and some of them are like paid tools in which like you can actually you can give your clothing, and you can change the model in the background, change the hair color, change the like skin tone. So it's interesting, like these problems are out there, and like there are companies like building like the exact solution, because it is costly. It is costly, and that is how the market works. Like every season your clothing changes, and you have to do the advertising for that. You have to take pictures. So it is amazing. Like this is the problem that she was asking, and there are solutions like for that kind of problem. So what was happening before that is, before like ChatGPT, she had this problem before as well. She never thought she would have a solution for this.
I see, okay.
And AI could provide that.
Yeah.
She could have never thought about it. But now, thanks to ChatGPT, like she thinks AI can provide. Like they come and ask me like, can we solve this problem or not?
Yeah.
And I can be like, yeah, you can. Like she did think about like, there is a solution to this problem, you know?
Yeah.
So that is amazing.
Yeah. Just to dig deeper in that problem, how is it mostly like they're segmenting away the clothes and like extracting the model and then changing out the background, or how do you think these are actually helped?
There's a lot that goes into it. Again, like segmenting reminds me of Sam too, but like I'm not like a vision expert, but for example, with the one in which the clothing item, I think you put your clothing item on a mannequin, and you take a picture of that, and then it like figures out, it takes out the dress, and it's able to put it on any like model. You decide like what kind of model do you want. You want a South Asian model with like black hair, or you want like a white model, whatever, like which diversity you're focusing on, and you can change, like you can switch the mannequin with that, and like change everything else is like Photoshop, honestly. Like you change like the hairstyle and stuff. So what I am thinking would happen after a while, or maybe it has started happening already, like advertisements would get so much more personalized. I would see a different advertisement, and a white girl my age would see a completely different advertisement. I would see someone like me wearing that clothing, and she would see someone like her wearing that clothing, which is amazing.
Yeah.
Like you figure out what is the kind of advertisement that that this person finds useful or is attracted to.
Yeah. Awesome. So on a lighter note, but now it's been a little while since you moved to Vancouver. You were in Toronto for a while. So let's get your opinion. So what's pros and cons of each city? What do you think? Now you've had the summer here, right? So you can give a better opinion.
So I feel like the tech industry in Toronto is a lot bigger than Vancouver. That's the tech part. But Vancouver is so beautiful compared to Toronto. And I love wildlife, and it's so amazing. I go on the seawall, and every other day I might see a seal, a crab, a fish, or something. Yeah. So it's amazing that way. Nature-wise, like I loved Vancouver compared to Toronto. Toronto also had lakeshore, but that's about it. Like it wasn't that amazing. Not that beautiful, but you could just see the lake going very far away, and that's all.
Yeah.
Other than that, food-wise, I feel Toronto is much better than Vancouver. I have this favorite restaurant. It's called Pai. It's a Thai restaurant.
I've been there. It's
in
good, yeah.
Toronto,
Yeah.
it's amazing.
Yeah.
I have been trying to find a good Thai place here. I haven't been able to. So yeah, that's what I feel Vancouver is lacking, like good food places.
Yeah, I think Vancouver does have good food, but it's very monocultural. Like there's a couple of like there's sushi places that are very good here, and then you have Chinese places that are really good, and then for other cultures, I think we're falling far behind.
I haven't been able to find a good bubble tea place. Like there was like the place I was living in Toronto. Like it had like 10 bubble tea shops right there in that vicinity.
I'll send you some recommendations.
So yeah, I feel like food wise, I feel like Vancouver is lacking, but it's beautiful. So many, like every weekend you have something to do. There's not just events, like you can just go out, like every direction you go out, and like you have some place to go to and like look around nature wise. So I feel Vancouver is amazing that way. Weather wise as well, I like Vancouver compared to Toronto. I don't like snow.
Okay, rain over snow.
Yes, rain over snow. Yeah. As an Indian, like I like drinking chai and eating pakoras while it's raining. I love rain over snow. I don't like extreme weathers, like not too hot, not too cold. So I like Vancouver that way. Yeah.
Awesome. Well, Bharat, thanks so much for your time. This is a great conversation. I think we touched on a lot of topics. And yeah, always appreciate chatting to you about AI. I always learn something. So
Thank you so much for inviting me.